Hey, Michel, thanks for coming on the Analytics Everywhere podcast. How's your day going?
It's going very well. Thank you, Srini. Thank you, Max, for having me. It's great to be there.
Yeah, great to have you. So to help set the stage and provide context around Airbyte and your kind of journey, I'd love to start with your background. So when did you first start playing with computers? What was your trajectory kind of after school and so on?
Yeah, I mean, if we want to go back to when I started to play with computers, we need to go back to when I was living in Switzerland. So before my 9th birthday, and I had some very good friends living in the house next door. And their dad was working in electronics, and the basement was just full of computer. Used to play Prince of Persia at the time, a little bit of Tetris, but that was my first exposure to computers. And then I went to middle school, and end of middle school, I started to work harvesting tobacco to make money, to buy my first computer. So I know I contributed to a pretty bad habit, but I would say for myself, it was for the good cause. I wanted to buy my first computer, and that's really when I started to.
That's in Switzerland, so people grew tobacco in Switzerland?
No, so this one was when I moved to France. So middle school, I was in France. But yeah, I started to just gather like as much information as possible on computers. That's when I started to play with Visual Basic and just Basic initially, and then Visual Basic to do my first programs. And yeah, that continued. I was a little bit also into the hacking scene when I was in high school. I did a few things, but nothing too.
Well, we have to take a comment there. And was that the VB stuff, Visual Basic, was that VB6? Or do you remember the version?
I have no idea.
VB6 was kind of cool. Like it was the first like Visual Basic. I think that was like somewhat usable. And there was a lot of it was a lot of no code. I mean, it was a coding environment. There's a fair amount of like all the GUI stuff was no code. So you would drag a window, drag a button, double click the button, and then it would take you to a text editor. I would say, button on click. I think like a lot of us learn, or people were around at the time, learned some UI UX patterns, and that made like building UX UIs for Windows a lot more accessible, which is kind of cool. Yeah, I played around I was in the BBS scene, in the 418, which was like the Quebec City scene.
Okay.
And kind of played with the BBSs and a little bit with the pirate BBSs at the time, which were pretty harmless. I think that whole scene, hacking, freaking, it was kind of a cool scene back then.
Yeah. A little bit of cracking as well. That's what this one was also fun. But yeah, I mean, I remember the first software, I had this book and I took the CD from it. And so I had like a free version of Visual Basic. And yes, it was the one with GUI and everything. And that was good, but it was a demo. So you always had this nagging dialogue coming up. So that was the first program that I wrote. And then, yeah, man. Went to a computer science college, studied there for 5 years, and that was very intense in terms of CS projects, and always like a good split between short-term projects, very long-term projects during the year, created games, some machine learning things, and just very Unix-centric. And after that, I moved to the US, did an internship. It was 2007. And I would say that was really my first exposure to data. I was not working on data per se, but I was working on medical data sets, like working on brain segmentation, just trying to identify different zones in the brain from imaging, from MRI. And like I was at Siemens, and at the time I had like massive data sets, and it was just some files in random folders. And I just spent some time during my internship trying to classify all this data, getting it organized so that all the other researchers can leverage it faster. And after that internship, stayed there. Yeah, it was for a year and a half approximately. I went back to Paris, and this is when I really started to work on data. I was at this company called FactSet working on financial data. And that's really when I learned about like these pillars of what does it mean to own a data pipeline. Like the first one, which is about the collection, extraction, then loading it into the database, and then actually making that data valuable. And at that time, it was for traders and for quant people working on estimates that.
Sorry, I've got a little bit of tangent that I'm going to take, but which is kind of interesting. I happened to live in Paris a little bit like earlier, but around that time, like 2001, 2, 3. I was working in data, so I was working at Ubisoft, a French company at the headquarters there. And then I remember having interns and people coming out of school that would have graduated from BI, like I think it was called informatique décisionnelle, like decisional. IT, I guess, which is kind of interesting. So there was already programs back in the early 2000 in France. I don't think in the US and Canada we had like BI specialized like school program. And then by that time, there's already all that theory around, ETL, business intelligence, and data visualization. All of this, existed. I was going to say long before our time, but or a little bit before our time, I guess, or a little bit before my time, for sure. It's kind of interesting.
Yeah, I mean, in the end, it's engineering. It's just you take a big problem, which is you have some raw data somewhere, you need to get it somewhere else. Now, how do you decompose it into sub-problems? So, yeah, extract, transform, and load is now it seems very natural. I'm sure there was a ton of research done. I'm sure that this is like a principle that exists since the 80s when computers really started to get very popular. But yeah, that's I was exposed a little bit during college on the concept of ETL and data management, for sure.
Why did you decide to specialize in data?
So one thing that I've always liked to collect bits of information. So even when I was in high school, I would just gather as much like hacking magazine, cracking magazine, just document all of that on my computers, organizing all of that. I had like a massive shelf of movies and games and just collecting things to obviously produce value from it. So I think it's more like a personality trait. And data is like all these little bits of information, and then what do you do with it? So yeah, I wouldn't say I discovered data. I think it's just something I actually did discover data at that point.
I think like a lot of companies kind of pushed us in that direction. So people who were just kind of software engineers interested in data, or just people in IT that happen to like know a little bit of SQL or help out with a problem. There would be a lot of draw to kind of push us and be like, hey, can you help out build, the data warehouse, the ETL, the visualization, the tooling.
Yeah. And it's something that's very clean. It's just, you can see the effect of every single step a piece of information is going through up to actually creating value. So I think the feedback loop also is pretty fast. So you see what impact you have with your daily work.
Yeah. Right. Makes sense. I guess and then eventually you ended up working on integrations at LiveRamp, right? Or maybe you got some inkling of the problem there. Maybe you want to talk about your experience managing kind of the integrations there.
Yeah. So in 2011, I moved to San Francisco, and I joined back in the day a small startup called Rapleaf, became LiveRamp. And this is when I got exposed to internet scale in terms of data. So it is an ad tech company, and it had a footprint across so many properties online and had access to so much data from customers. So this is really when I got very, very deep into what does it mean to manage data at scale? What does it mean to manage petabytes of data? And I started there, build basically the seed of what data integration was at LiveRamp with all the framework on how do we quickly add new integration to new partners, because the ad tech world at the time was extremely fragmented. So you had like 200 doing attribution, 200 doing video ads, etc. And you needed to integrate with all of them and make sure that all this flow of information passes through IRAM. And so I stayed there for six years. And when I left, I was leading a really large part of the engineering team. And we were processing hundreds and hundreds of terabytes of data, like new data coming in every single day, whether it was like traffic data, whether it was CRM data coming from our customers, and whether it was just sending that data out to different vendors in the ad tech world. And yeah, the team was about, I mean, the part I was managing was about 35, 40 people. And yeah, that was, we had to learn how to manage like these thousands of different integration, how to do it at scale, how to do the maintenance, and how do you build the team and the processes around it. So I got a lot of scars from it, but I think that's the type of scars that I'm leveraging today with Airbyte.
Yeah. Like talking about this problem of like data integration at scale, to me, I feel like the volume stuff, like the volume challenge is something we can really tame and control, right? Especially nowadays, it's like post big data world with the cloud data warehouse, with like Lambda functions, right? Or like just really easy to get like serverless stuff and get resources as you need them. Like elastic computing is all figured out. So I feel like volume is less of a challenge. It's more containable than the problem of like the sheer complexity of the integration, right? The number of integration that a typical company needs nowadays, and change management around that is the real like beast, the challenge for Airbyte, the challenge probably for companies similar like Fivetran too, right? Where you got a super long tail of like SaaS services, all that silo data, you want to bring it inside the warehouse. Actually, you don't just want to bring it in the warehouse. You also want to get it everywhere, right? You want to reverse ETL it, or you want this mesh, this fully data integrated, like master management type solution. I think that's like a very difficult problem, and one that you guys are taking on kind of head on at Airbyte, right?
Yeah, that is true. I would say scale. Once you've sold above 1 terabyte of data being like flowing through your pipes, yes. After that, everything goes flawlessly in terms of scale. Once you start getting to the hundreds of terabytes, 500 terabytes, then it's not just about scale, it's more about the speed. And this is what you need to solve.
Right? Or it becomes like prohibitive, right? So it's like, you care about it because it's expensive, right?
Exactly. But I agree with you. But you don't handle a system that moves 1 gigabyte the same way you manage a system that moves 1 terabyte. Like there are things that you need to address, but then yes, it's a step function, and that step function gets you a very long way. Now you're right. Like the real problem and the real challenge with data integration is the breadth of where you have data being siloed. And it is the fact that not only, you have an infinity of places where you can have data, but also it's systems on which you have zero control. So these systems are always going to break. Like anyone who tells you like our integration 100% reliable, that's not true. It is impossible to have something because you have no controls. Google tomorrow can decide to change an API. Zendesk can decide to change an API, and your system is broken at that time.
If they do it well, right, they create a new version of that API and they sunset the other one. We all know how it goes in practice. But yeah, we should get into that too. I don't know if we decide to go into this question now or later, but like the way that this stuff is built is kind of a byproduct of how things have been built before in some ways, right? So like, a company like GitHub's going to open up a REST API, maybe a GraphQL API, and then you guys at Airbyte, kind of figure out what the APIs are and then try to create a model on top of it. It seems like they could just expose something different, like maybe a CDC, pipe, right? Or different. There could be some standards that are better than going through REST. Like REST seems like a really bad interface to try to do data synchronization.
Yeah, I've always wondered that as well. Like, especially for companies where they want to like either sell data or like build an ecosystem, or whatever. like API is fine for like a little app that you're building, but yeah, I worked at a startup where we were syncing data from, where I managed all the logic for wearables APIs, and it was just such a disaster. I'm like, these are not meant for data exhaust. It's meant for
that's
like,
it, right? REST is meant to like, hey, I'm building a UI and I want to get, a sheet and populate it. I want to get a list of things and put it in a table. But it's not like, hey, I'm trying to now we use the same API that was built for something else to try to do data sync. And it seems like such a burden and such like a difficult step to go through.
Yeah, but that's actually normal, is because these applications, all these SaaS services, they are not here to sell you data. They are not here to give you, like to get data into another system. Like all these APIs is basic, like these are their product. It's how you interact. It's another way of interacting with their product. They have a UI, they have an API, and you interact with the product through the API and through the UI. And
yeah, I think that's totally true. But like, if you think about, so that's your data on their system, right? In some ways, like if you think about like your CRM data on a HubSpot, on Salesforce, it's my freaking data, give it back to me, or I need it in my systems too. I think that's not a bad, claim to say like, hey, I should have a way. And I think like ultimately SaaS services will have to offer that. Like for me, I would not buy a CRM if there was no Airbyte integration, right? Like at some point that becomes just a thing. And then, I think it needs to have an API. Maybe we need another thing, a new standard that's like, a CDC construct of some kind that is more direct, right? That is offered by all these SaaS applications to just say like, okay, I can do the sync.
Yep.
But at
the same time, you see that they probably, like this company might not want that to become just create a parallel system to what we're doing. So you still have access to data, but it's not meant to just suck up all the data from their system.
Yeah, it's a moat for them, right?
Do they actively, they understand that their system is more sticky? I mean, that's the whole like Oracle thing. Like Oracle makes it really easy to load your data in Oracle, but like impossible to extract it. And that's just like they want it to be sticky and they want to lock you in and all this stuff. But I think in the world that we live in, is just going to be like super important for all of the vendors to offer an easy way to do data integration. And that could be through a partnership, with you guys. But for me, I would just not buy these systems anymore if they don't have good APIs or good way to extract and synchronize the data.
Yeah. I think the day reverse ETL is really, really mature, that will also change how this company sees data, because they are not just a store of data where you can extract data from. They also become a destination. And at that point, they have there is a very strong interest for them to let the data flow through systems and come back from the other side. Because that
give it, take, So you give it, but you receive too. It's more of a
exactly. And that makes their platform way more valuable the moment you can start acting and be and provide data in an automated way that makes this platform more valuable. So I think the stickiness at that point for this platform isn't just going to be about the data that is stuck in their system, but more about how they allow people to inject more data.
Yeah,
that's probably like That's probably what like Zapier's pitch is as well, right? Like they go to like companies and they're like, look, you don't have to build your own simple like notification, alerting, synchronization thing. Like we'll work with you guys to make that just available easily. So that's probably like a similar pitch where it's like, your customers are in an ecosystem. They're not just using your tool. So you probably need to figure out how to talk to them.
You know how the term, so data mesh, kind of branded a thing that no one's happy with, like the definition of it. A lot of people are redefining data mesh. So my redefinition, if I could take these like two kind of marketing words together, these two concepts together, what I would call data mesh is the ability to take all your SaaS system and do master data management or like to synchronize them and send a mix of like, referential data and analytics data across, so that tools like your CRM as context about product usage and your employee kind of or your what's it called, the recruiting kind of stack too is cohesive with itself, with the HR stack. All these things are integrated and working well. And I don't know if the pattern of like bringing it all to a warehouse and then shipping it back. So the reverse ETL pattern that depends on the data warehousing process kind of works, but super batchy and laggy too. So I feel like we need something that's more of a message bus hub type thing. I don't think there's commercial solutions. I mean, there are like things like Segment can kind of synchronize your marketing data and do things, but still very primitive.
Yeah. I think if you see the data warehouse as this is my master data set, the thing that controls what my data, it feels like, yes, you have a bit of centralization, and that goes against like data being available into other systems. But if you see data warehouse more as like, this is my compute engine, and I just want to shove as much data there, and then I can do my computation, and then feed that computation, like feed the results elsewhere, then that changes how you're thinking about a data warehouse. And every single node in your data mesh now is composed, they need to have a compute engine, whether it's a warehouse, whether it's a spreadsheet, whether it's a shell script or whatever, they all need to have this compute engine. So looking at data warehouse, not just as this is where I have all my data, but it's more like, this is where I do my computation. And now my data can move to and from. That changes then how people can think about data warehouses. And that works more with let's get the data where it will have value, and let's make sure that the people who know what value to extract have access to a powerful compute system and engine.
Yeah, at Airbnb, we had a system, I forgot what it's called, but it was like just a big Kafka queue for, and I think like these things have different names at different companies. I'd lived like the whole Envoy and service mesh thing allowed for services to talk to one another. Sometimes it's through RPC, like the remote procedure calls that are kind of instantaneous. So it's like system talking to systems in real time, which is kind of cool. I think like Google's got a bunch of that internally. Like they invented, I don't know if they invented, but they're behind Protobuf and a bunch of the RPC stuff. We had a bunch of that at Facebook too, through Shrift. So that's another way for services to kind of tap into some sort of centralized bus and talk to one another. So say when there's a booking happening at Airbnb, the booking service emits a message, and a bunch of other services like the fraud detection services and the refund service or whatever it might be, they all tap into this event and do work and kind of integrate in real time, which is very different, but similar to the reverse ETL use case in some ways.
Yeah. When we look at data like this way, we think of one is the analytics use case. The other one is the operational use case. What you're describing is with the bus is more like the operational use case, meaning that the consumers and the producers are not human beings, or they can be, but they won't operate at the scale of a service or like a program. And if you separate the two, then you see that, yes, one requires a message bus, but the other one requires a warehouse, something that is more like you can interact with it, you can do queries, you can extract, and then you can say, okay, you know what? I have these results. Let's feed them so that all my systems can now have access to this new information. And whether you want to send it directly to a service or to an API or just to a queue and publish new messages, this is something you can.
I think there used to be like a more clear distinction too between operational analytics and kind of strategic analytics. Historically, there used to be something people would call an ODS, the operational data store. People kind of disagree on different like kind of theories. So I think Kimball, so the two grandfather of data warehousing, Kimball and Edmund, kind of disagreed on exactly what was an ODS and the role of it. But typically it was probably more real time to support operational use cases, more normalized too. So the data structures would be less oriented for big scans, but more for like getting lists of invoices in a certain state, and things like that. And that construct is kind of gone. Like I haven't heard the term like operational data store in like 15 years. I think.
It's just it has changed. It's not that it's gone. It's just that it has been modernized. And when you're thinking of Kafka, for example, this is exactly what it is. It's just you have extremely structured data that flows through it, and you have systems that connect to it and just make very fast decisions based on every single message that they receive. But then you also need to have warehouses because you need the data to be stored somewhere, and you need also your team to be able to discover, okay, what is the next generation of things I need to do? What can I get from the data that this service that operates without a human, like how do they need to evolve to be better? Like you were talking about fraud detection. Your service V1 operates on some principles that you have, but now you need your team to actually dig into the data and figure out, okay, what are the other signals I need to be looking at for my fraud service? They experiment with it, they do the analytics, they come up with new rules, and then they create the V2 of your fraud detection service. So that's how like the analytics system feeds into the operational system. But you need to have someone behind the scene that just digs into the data, like apply some machine learning algorithm or other to just figure out, okay, what is the next version of my operational system?
Yeah, I think there's probably a really interesting blog post there to maybe call something like, the death of the operational data store and how like modern organizations solve operational analytics. Because I think like Kafka as a part of it is kind of like Kafka is kind of timely. You'll have like a week or two of data. Data is not indexed in it. If you're like trying to search, for invoices in a bad state or like things that it's more like keyed access to fresh operational data. So Kafka is not it. The data warehouse, it's like you're going to have to do the big scans to kind of go and fetch a few invoices. The system is not oriented for that kind of workload, though it works, right? So maybe it's like the new kind of cloud data warehouse are able to do large scans to get a few rows too. So I think that's part of it. And maybe some of that workload is like happens in SaaS tools directly, right? If I want to get the 3 invoices in a bad state, maybe that's happening in my accounting like invoicing system, and they've solved that as part of the application design, and this like so operational reporting is part of the SaaS kind of service use case, solved by them, so we don't need to do that in the warehouse as much.
Yeah.
Cool. Well, I know we're deep into talking about data integration, so there's actually a good segue into how you guys started at Airbyte. So my understanding is actually you guys got into YCombinator with a different idea, still around data, but around something different. So maybe you want to talk through that journey a little bit, and then your kind of discussions with customers, to help you identify kind of the challenges around data integration, and then the pivots. I'd love to hear like how that all played out.
Yeah. So before we joined YC, so it was in 2019, we had an idea around how can we help companies exchange data with each other, whether they are a data broker or whether they are just they own first-party data and they want to do some program with partners and exchanging data so that the two of them can work together. And we went to YC with that idea, and after 1 week, we said, okay, let's go for another idea, for something else. YC is what they called us like pre-idea type of companies, and that's when they really look at, okay, what did the founders do in the past? So it was more about the team than the idea itself, and we just went for just calling. We had like this automation for reaching out to people on LinkedIn and trying to get on the phone with data engineers, with like data sellers, data buyers, etc., to understand like what needs they had. And as we were doing it, we actually started to talk to marketing teams, which is, we need more data. We need to ingest more data, feed that into warehouse, and have better automation and better targeting of people. And say, okay, let's find another idea around how to get more data to marketing people. And this first idea was called Data Line and was pretty successful initially. And the idea was, how can you get more event data and making sure that you don't lose your events when people are browsing on your website, on your product. And that was pretty successful at the beginning. And then March 15, everything just stopped in the world because of COVID. And marketing teams stopped answering us, and they stopped implementing our tag on their website. And we still had like some we were still able to get conversation, but we were not able to get to the point where they were like production users. And that's when with John, so we tried to push this idea as much as we could. And then there was a moment, I think it was in May, beginning of May, we said, okay, that's not the right, we're not building the right product. And also the fact that we're going more on marketing just was pulling us away from our core competencies. John, who is in dev tool, and me, who is in data, like pure data, and also the person that we're more familiar with. And that's actually when we started to go back on all the conversation we've had. And whenever we're talking with marketing, they were also redirecting us to data teams and what kind of problems they were having. Because every time they needed to do something, they needed to talk to their data teams. So we went back, tried to contact all these people we've talked to in data teams, and looked at, okay, what is missing? What is the world not solving for you at the moment? And what are you spending your time on as a data engineer? And that's really when we kind of settle on the data integration space. There were already some players, and having been in the data integration space before, while I was at Liverum, like there was something that was not working in the solution that were available today, which is every single company we're talking to, they were buying a solution, but they were also rebuilding their own solution on the side, and they were hiring people and building large teams to just manage this integration again. And that's when we just thought about, okay, one way we could do it is, what if we make it an open source software where what we offer is a platform and then tooling to build and maintain connector faster? Because generally building is easy, maintenance is really hard. And we actually reached out to many existing customers from existing solutions like Fivetran, Matillion, and others. And we were talking with them and we were trying to understand what is not working with them. And there were basically four main things. One was extensibility of the platform, customization of the platform, pricing, and control over data, which is there is data sets that they cannot send to a SaaS service. And that's really when we settle on this idea, which is, okay, let's experiment for 1 month. Let's see what we can get to. And after 1 month, we're like, okay, let's do 1 more month because we're getting very positive signal. And then we say, okay, let's go full speed on this one. And we released Airbyte at the time. It was in October 2020. And yeah, since then, and what we've done is actually we've reached out to all the teams we've talked to in the past and say, Airbyte is very much in alpha at that time. You want to give it a try and give us your feedback. And from there, like the usage started to go up and the community started to grow. So
I'm curious on the story too. I think you guys like at some point maybe reuse some other open source project. I think Singer might have been one of them too. I think a lot of us the experience working Singer, it's like maybe better than starting from scratch, but also like it's not always easy, right? Like some of the connectors, you don't know the grading of the quality and the maintenance. A lot of these things that have been kind of built and thrown over the fence are not really maintained. And then sometimes there's like, I don't know, it's so tempting. Like part of the issues with data integration is like you want to throw in a few business rules. So, I built a bunch of these connectors, while at Airbnb and other places, or inherited, say, the Zendesk connector. And then like, oh man, I wish I could just like, if we're going to do a good job at this, I wish I could just open source it and share it. But then it's often, entangled with some business logic or some like, sometimes it's just like, hey, I really care about these 3 or 4 entities in Zendesk, and then we don't use these 12 other entities. So not just the long tail of systems you want to integrate with, but the long tail of, the information architecture within those systems, right? Like Zendesk is like, I really care about tickets, but they have features around like, I don't know, chat sessions, and we don't use that at Airbnb, so I don't care. Someone else might really care about chat sessions. So then you end up with just like a mess of connectors that are not super well maintained. So curious, like the entanglement, like maybe you started with some of these connectors and evolved them or forked them. How did that go?
Yep, absolutely. We actually did that. Like, when we were doing this experimentation over the first 2 months, the thing was, let's go and experiment as fast as possible. And we took a few single connectors and we started to build around them. And in the second month, we're actually spending more time trying to understand why would this behavior happen within Singer. And what you realize is the way. So first of all, I think the intention behind Singer is great. I mean, we obviously we share the same one, which is making sure that people don't repeat building more connectors, and also having a platform to, as you said, not just go for the breadth of connector, but also go to the depth in every single of these connectors. And the thing that happened is there were very, very little enforcement on how a single connector should work. And what you would see very often is that because people were controlling both the source and the destination, they would actually pass metadata that would change the behavior at the destination level. And suddenly you've created this weird dependency between sources and destination, where the destination will not work if the source is not providing this information. So you're basically creating new families of connectors that can work with each other. And so it breaks this idea of sources just need to be implemented once, destination only need to be implemented once, and then you can have like this cross product between the two. And that was really the problem we've had. And then we said, okay, we like what they've done, but we can push it forward. And the first version of the Airbyte protocol that we built was actually, it's inspired by Singer. We mentioned that in our documentation, which is the way messages are passing, the type of messages. We have something similar. So we can translate, for example, like a connector that is Singer into an Airbyte connector. The other way around doesn't work, but that was the intention, is also starting from something that is fresh with much stronger rules on what does it mean to build a good connector, and what does it mean to, like, what you can and cannot do. So it's about adding limitation to your protocol, while also thinking about extensions.
I know,
but it has to be defined as a protocol, because if it's not a protocol, then people are just going to do whatever they want. They would just invent new messages, and suddenly the destination on the other side has no idea what's happening. So you want to make sure that you have a strong framework that prevents people from just doing things that are extremely custom to what they're doing, but really think of it from the top, which is, this is the data. It's not about, I want to trigger a behavior on the other side. It's just, this is the data, and this is how this data is flowing.
Yeah, one thing is the data modeling, approach, right? So one approach, I would say the 5-trend approach seems to be like very like 3NF, like kind of third normal form. And then like really trying to get all the entities right. And I guess you look at the REST, the API, and then you get a pretty good sense of what their internal model is. And I think like the 5-trend approach is like just trying to replicate that model inside your database. I've seen other connectors. I think some of the Singer connectors, I guess they're all over the place, but some of them were more like, hey, we'll just have like a key, the simpler model you could have is just to say like a key value store and just say like, here's an ID, here's an object type, and here's a JSON blob with everything we know about this object or everything that has changed about this object. And maybe you need the two, like maybe you need to have the first like kind of message bus that's like very generic, and then recompose that schema. But there's still a lot of like data modeling constraint. Like even I was working with the GitHub data before, and in GitHub, there's weird entanglement between an issue is a PR, but it's not quite a PR, a pull request, and an issue. And the discussions, they're kind of all the same thing, but they're not really the same thing. So at some point, someone designing the connector is going to have to say like, oh, these are 3 entities, or they're just one entity. And then that might work. Then it's like a judgment of like, oh, this works better for me. It might not work as well for someone else. So it's subtle. It's like the art of data modeling. I don't think it's a direct, like based on the REST API, you can have a deterministic, data model. You still have to make some like that art kind of judgment of data modeling, which is really, really tricky.
Very, very true. You know what? Just before coming to talk to you, I was reviewing a document exactly on that topic. So we call that normalization. And our belief here is that the source should stay as close as possible to the raw data. We should try, to a point where once you've implemented how you pull data for one stream, we call stream like a type of model. You should just be able to do a for loop on a list of names, and you manage the other stream the same way. So no business logic in there. Just stay as close as possible, while still trying to extract, okay, what does the schema looks like from the API? So whether it's documented by the API, whether it's something you can infer from the data you're seeing. And then on the destination, today what we're doing is we're just showing all that data. We have what we call these raw tables, and we put just all the data there. And this, by doing that, you've already accomplished a huge part of the job, which is removing the complexity of integrating with external systems. But just like the physical complexity, like how do you connect? How do you get credentials? How do you maintain this connector? But you're right. After that, you still have to do the data modeling. But the problem is like the data modeling is generally very, very tied to the analysis you want to do, or like how your company is operating.
So that first step, do you include then columnizing and like entity creation, or just like kind of key value store? Like we'll just dump everything into like blobs at that point?
Yeah. Today we do that. We have this key value store. This is the raw tables. It's just one key that we've identified from the model. So this is where you need to use judgment as someone who implements the source, and then the blob. And that's
you just bring that to that schema on read at that point, right? And then after that, I think it totally makes sense to decompose the layer. First thing is like get all the stream of object. That's what a CDC stream looks like historically, kind of, or I don't know. A CDC stream can be different things, but just like, give me the list of object and changes and like kind of raw, like everything is a key and a value. I think that makes sense. And then after that, the art of like how to remodel that into like a third normal form, a normalized schema. That's where the art is. And we might decide to use, say, the Airbyte integrator and just tap into that lower level, and it might work for us, right? Or we can decide to like the more fully normalized integration.
Yeah, and this is where actually, especially with Airbyte, we need to think about what do people want for that? And the thing is, everybody wants something different. So the first thing is, let's make sure that this, what you call like this key value store is there. Today, we're trying to also make it a little bit simpler by just breaking down these models and have like automated table creation based on what the models look like. But even there, you have some API where this is extremely noisy. You take an API like, I don't know, Salesforce, they have like tons of nested records and schemas. So when you start breaking down all these schemas into tables, I mean, your data warehouse ends up with 1,000 tables, and you don't even know what they do, because it has been exploded.
And yeah, there's dynamic schema there too, right? And you can go and create your own entities in Salesforce. So like, I'm going to create a concept of a team that, is one-to-many with the notion of Salesforce as a company. So you can, now they have like dynamic schemas too, right? Like especially in CRM or, historically in ERPs, you could kind of do development. You can, people make a living out of customizing things like Salesforce too. So what does that mean on the data integration side? How the heck are you going to do dynamic, data integration? Gets tricky.
Yeah. And that's why you want to back again to like the fundamentals, which is you want to decompose the problem. And first is let's get the data there, because once the data is there, then whether you can automate or whether you're asking a data engineer to look at what should the data look like, or some data analyst to say what should the data look like. I mean, you can decide this next step, but the data is here at least, and you don't need to spend hours and hours just pulling that data away from pulling that data from these sources. Now you should also come.
Pause it for a second. So one thing, like tying to something we were talking about earlier, which is like how REST is not the right interface for this. So now that you have this, like, call it this interface that's like key value of what has changed, that looks like a CDC stream, you wish like every freaking system out there would have a REST endpoint that's just like, give me the list of objects with a blob of what has changed. You know what I mean? Like that would be so great, instead of having to like hit like 600 freaking like REST endpoints, and hoping that they've indexed on last modified datetime, and hoping there's a way for you to page through this stuff. So just give me one freaking endpoint that's like which objects have changed,
Yeah. But that could solve a part of it, which is you don't need to scan through hundreds of endpoints to find what has changed. But it doesn't really solve the modeling of the data, because even if you're pulling data from Salesforce, they will still give you a blob of data. This is the record that has changed. If it has nested record, what is should they also include the nested record? How do you consider that this? So you still end up with the destination side is still the same thing. Just you have a blob of data somewhere telling you that something has changed. So here we're just removing that complexity. Yes, if tomorrow everybody is Salesforce or a Postgre database, I think Dropbox and Google are pretty good at it, which is give me one endpoint where every single changes is there. This is great. I mean, that makes everybody's life much easier. But the thing is, people don't think of
the complexity of your connector, right? If you think about building a connector, part of it is the scraper side, and you have to deal with rate limiting and all this crap and all the points that are changing, right? So that's probably half of the complexity of the connector, if not more, the interacting with the REST API. So that'd be really great if someone is hey, here's the standard. It's super simple. It's key, blob, and metadata endpoint. It's for each key type, tell me what the column, the structure is or something like that.
But then maybe the first most popular companies are going to do it, but you will always have a long tail for whom it's not a priority. And then you still need to have a system that can do it. And it's not you can say, oh, it's plug and play. It's the same thing when you're thinking about GraphQL. GraphQL is a great interface for querying data, but the thing is GraphQL leaks a lot into infrastructure. How do you dispatch queries? How do you do load balancing and all of that? And that would be the same for CDC, which is you don't know behind. I mean, it's not you can just put a small module in your API middleware to say just pull all the CDC. No, it has to integrate with how your data is stored. It has to integrate with. So it's a very complex thing to
complexity
expose.
on them. Yeah. So instead of you dealing with that complexity of scraping through the complex REST API that they already have, it's for them to somehow centralize. They have to manage it, some sort of stream, something that looks like it's a CDC stream, and make that an API. So I think that pushes the complexity on them, which is probably where it should be. But at the same time, here's the thing too, is customers are not going to go and ask Salesforce for that directly. It's the partners, right? So it's going to be people are oh, I want a Salesforce. I use Airbyte. I want for Airbyte to have a great Salesforce connector. And the people at Airbyte or the open source community maintainers are going to go to Salesforce and say, that'd be really great if you subscribe to this non-existing yet standard, or if you had something that looks more like a CDC stream. And then I think that chain of requests probably just fails, right? And there's no emerging standard. There's never been a B2B data exchange emerging standard, or there was one I know for retail. So when I was at Ubisoft, we had an antiquated, what was it called? It's a 3-letter acronym for, companies Ubisoft and Walmart to exchange inventory data. God, what was it called? Anyway, so these standards though, I wonder if maybe that's a question for you. Is do you see over the next 5 to 10 years, the standards evolving for data integration and data exchange, or supporting this idea of data mesh that we redefine here as any system integrating with any system?
Yeah, I mean, we would love to do that. We would love to do that. Creating standards takes time, but this is really something we want to push for. On one end, it's about how should the data move between point A and point B, and the other one is how should you expose your CDC data. But first, let's get the data in. Let's remove this complexity for data consumers and data users, and then let's see about where the data is coming from. Is there something that we can help build to make the life of data consumer even easier? So this is something we've thought about. but we're also a startup.
Yeah,
First,
yeah, but it's like, or maybe it's like, another question would be like, are you optimistic or pessimistic? I think we all agree that we need better standards and people need to implement them over time, and that's really critical to build the modern world, the modern kind of tech world, and the ecosystem of SaaS is only going to work, and the analytics ecosystem are only going to work if we have better, or it's going to work much more efficiently if we have these standards. But are we optimistic that people will that these standards will emerge and get used? My read on it is like, I'm not super optimistic that over the next 5 years we're going to make a lot of progress on that.
No, I don't. I'm not that optimistic. Now we can start to evangelize a little bit on this, but I'm not that optimistic. And the reason is the same. It's, as a vendor, as a SaaS service, you always need to ask yourself the question when you're creating a scenario: what value do I get? And I think today we're missing pieces around what value would they get for them to actually prioritize that, because people don't just implement standard because they want to implement standard. People implement standard because it brings them value. And that's why that goes back to what I was saying at the beginning, which is, if suddenly you said that you have an interface, a standard to ingest data and to ingest operational data to update your schemas, then suddenly you have an incentive in just letting the data go away from your system. But you need to, like, a standard only makes sense if people get value from it. They're not just going to implement a standard. Or they will, it will work for 1 month, and then it's over.
Yeah, and maybe, the problem maybe is just solved by Airbyte and, Cotillion and Fivetran, right? Instead of saying like, oh, we're going to solve this with better standard that we all subscribe to. It's like, we're all going to pay these companies to solve that for us, and then you manage that complexity. And then we just end up with data sync is largely solved. Like if you look at the state of 5 years ago, as companies like Airbnb had to write a super stupid Zendesk connector that broke every other day, right? And that's super brittle, super painful to manage, barely work. The data model came out of it was funky. So now at least we're at a place where you can pay someone and get your Zendesk data delivered to your warehouse every hour. It's a lot of progress already. How it's done is might not be the most elegant engineering solution, and a little bit painful, but at least we centralize that problem into a handful of entities that can solve that for us, which is progress.
It is progress.
Nice. So earlier you were talking about companies having to need for them to maintain their own kind of data pipeline, data integration logic with extra connectors. How does Airbyte kind of solve that problem? What is the solution that you guys came up with that you feel like is making progress on that problem?
Yeah. So the first thing is, you need to abstract away what data movement is. And this is the first step. You need to ensure you can have full compatibility between what the data is and where it should be going. Not saying that it's always possible, but so far we've been focusing on where it's possible. So once you've decided on what data should look like when it's outside of a system, then it becomes a matter of how do you enforce that type of standard? How do you guide people to build connectors in that way? And building, as I mentioned, is easy. So let's first get people to build. And as people build, they will also see the value in a platform, and they will start using other connectors. And if these connectors, they have agency on them, then yes, they will still have, people still have to do work on these connectors. They still need to maintain the long tail. So to build the long tail, so building, and also go for more depth, like maintenance. But the thing is, if there is value, if they don't have to work on everything that is around it, and they just focus on this connector, then this is why we built Airbyte. Is we believe that having a strong community of users gets us there, which is you crowdsource the development and the maintenance of data connectors. But for that, you need to have standards, because you cannot just let anyone do anything on a connector. Otherwise, you end up with exactly what happened to CEO, where people just put anything in a connector and you've lost control. And just, you don't know, you have like 10 different Salesforce connector and you don't know which one is doing what, what dependencies they expect on the destination side. So, and that's really what we've been working on. I know we need to continue to improve on the developer experience on that front, but if you enforce rules, then you can also guide, we guide our teams, you can guide the community, you can guide contractors on what does it mean to build a good connector. And you need to enforce your vision on what a source should look like. Always taking into account.
Makes sense to me. I think you want something that's like framework heavy, right? Like kind of like horizontal heavy, of like super opinionated, make it really obvious and easy for people to do the right thing in terms of designing their connector. Have the layered approach too, where you have like maybe that kind of, I forgot what you call it, but like that staging area or that staging area that's like entity free at first, or like that offer. Do you have a name for this like layer of the integration?
Yeah, like we call them like certification.
Okay.
But yes, that's exactly what you're saying, is that first, and that's exactly the life of an integration. It always starts very bare bone, no rate limiting, pro schema definition, some streams are missing, etc., etc. But what you want is to make sure that it is visible. So the moment someone wants to use it and they realize, oh, something is missing, rate limiting is not working, they have two choices. Either they build it on the side, so they start from scratch, or they take something that already exists with good standard and they decide to add it. So instead of having like, I would say like a full refresh build, you have an incremental updates you have to make as a data engineer on the connectors. And that's really like the motion we're creating. And then as more and more people are using, we track usage of every single connectors, like how many people are actually using it, like how many times it's failing, etc., etc. Whether it's on cloud or whether it's on open source, we track this information because we use these metrics to decide if a connector is mature enough to go to the next stage. And every stage has a limit on how many users are using it. If it's just 2, it cannot be a GA connector. It doesn't make sense because we haven't tested all the edge cases. We haven't gone into the depth. So that's like all this path is really what is the depth of your connector.
So your role kind of as a platform too is like to help people push these connector up the maturity lifecycle. If there is such a thing as like a maturity lifecycle of a connector.
It is,
right?
Exactly that.
Right. So then you want to enable the community of users to push all the connectors up their respective, maturity curve and make that easy for them to do. That sounds cool. Because it's really hard to get open. There's some things that open source communities do very well, and open source works very well at certain things, and then not so well at other things. And I think for you guys, it's really key to make it easy for people to do the right thing.
Correct. And this is, we have a team that is dedicated to like, what is the next type of tools that we need to provide? Because, we can only know how good it is by having people test it. So as people build more connectors, they give us feedback about, this part was terrible. I like running, end-to-end integration test was an awful experience. Can you help me there? And as we get all of this signal on the tooling side, we figure out, okay, what tools do we need? What leverage do we need to build for our community and for our teams to be more efficient and to spend less time writing connectors and maintaining them?
How do you guys incentivize connector quality? Because I know that you guys probably do a lot of it yourself, but also lean on, I imagine, the community to, if not create new ones from scratch, at least, maintain some of them. So I'm curious how, like, I've read some of it, so I won't spoil it for the listener. I'm curious how you guys incentivize this.
Follow up or like something that's integral with that. It's like the distribution of like who's working on connectors. Is it like a handful of people managing a lot of connectors, or people typically just work on one, or a small group of people really focus on one connector? How does that shape out?
Yeah, we have a little bit of everything there. We have people who just, like, typically we have someone who submitted like a connector to pull COVID data from a CDC website. Boom. It just did it probably for a research project. The connector is there. Now we have other people. Typically, there are some companies that are using Airbyte, and they build 10 connectors. Maybe 5 of them, they haven't published them because it's internal API, but 5 other are now part of the open source project. So we have every type of things. And also we provide our own connectors, which is we work with the team, we also work with contractors, and we like work with them on like, okay, what are the, it's always the same thing. You need to bootstrap something. Like when you're starting a standard like that, you need to be the first one to experiment with what this standard looks like. And that's what we've done at the beginning. And today we're working with contractors to help us build some of them, but we're getting more and more. And it doesn't matter so much that it's only one person building it. What matters is that these connectors have usage, because that's the only way they can graduate, and that's the only way they can be improved. So then it becomes our responsibility to make sure that these connectors are visible within the Airbyte community and within Airbyte users. Now, in terms of incentivizing, there is something that we're playing with at the moment, which is we're trying to do a bit of a bounty system for people if they want to really own the outcome of a connector. We can make them
like a connector marketplace. Like maybe you can sell your connectors, or you can based on usage, get recognized for the work.
Yes, exactly.
Very cool.
You got it. But so this is something that is more that's more in the work right now. We need to also make sure we have very strong fundamentals on how do we build and making this experience extremely flawless.
Curious, like how the distribution on the maturity life cycle. So if you had like a plot that would show how many connectors do you have and where they plot on their maturity life cycle. Like you probably have a handful that are top maturity, like maybe your Salesforce connector is like the most mature one and most usable, or maybe it's the most like broken one. There's like 20 version of it with different flavors, like vanilla, chocolate, Salesforce with a side of cheese. I don't know, but yeah, the distribution there's probably a very long tail, like not super well supported. And for me, I'm like, I think it's good to show everything, like to kind of open it up and just say like, as long as there's the right disclaimers that says like, hey, you can use this connector, but it is in a pre-alpha stage.
Yeah. And actually all the connectors, they are labeled. Like we're very transparent, and we're actually, even if you're configuring them through the UI, we tell you what it means for a connector to be GA, for a connector to be beta, for a connector to be alpha, or for a connector to be just a baby connector. So we're setting this kind of expectation on the product users. Now, if you look at the distribution, I would say we have about 25. I think we're going to get to 30 of GA connectors by the end of the quarter, so in the end of September. But then we have a big block in beta and a big block in alpha. But the idea is just the more the GA connectors are being used, the more you discover the betas, the more you discover the alphas, and the more signals you're giving to the community and to the team on what is not working with this connector. So it is important that GAs works really well and that it pulls the other one up by just exposing beta, alpha, and untagged.
Yeah, there's a lot of people in open source that are just looking to like get kind of a quick value out of things, right? Which is like, I have nothing against that, but you have the choice of saying like, hey, I'm going to take a beta connector. It mostly works for me. It's maybe 70% of the way there, and then that 10% extra that I need, I have the choice to kind of entangle with the community and try to contribute back and help out and improve the thing, or the option to just kind of fork and make it work for me and never talk to anyone. So curious what you see there, especially I get surprised. It's cool that you have usage data from the open source community. We're not really allowed to do this in Apache. software foundation based project, right? It's kind of tricky where if we release those features, we got to put it behind a feature flag that's off by default, and then it kind of defeats the purpose. But you guys are probably able to get more data. So do you see a lot of people kind of forking and doing their own thing versus people trying to contribute back and improve the connectors?
There are people who fork, for sure. And it's okay. It's okay. I mean, you cannot force people to contribute. I mean, there is always a cost in contributing to an open source project. But we try to encourage people to do it. But what matters is not that one is fixing on the side. The thing is, if you make the experience simple for someone to contribute, and you make sure that people understand what is their responsibility, which is maybe they should not have a maintenance responsibility on connectors, they will feel more inclined to actually contribute back. But yeah, that's why like having a good experience as a contributor is important. You want to minimize friction, you want to minimize effort, and some people are forking, some are not. It doesn't matter for us.
Yeah, one thing is like how fast I'm gonna get input, right? So community support, right? So say if I'm working on a connector and I figured out it's not working very well for me, then I might go on Slack and talk to someone or open a quick PR, see if anyone bites. And it becomes really hard for us, a commercial open source company, with like massively successful open source project with long tails of connectors. Like for us, it might be our on the Superset side, it's like database engine, support, right? Someone's trying to make an obscure database work very well with Superset, and there might not be someone to help them out, see the stuff through, right? And then at that point, they're kind of forced to fork, and but it becomes like just a challenge. I don't know how you guys deal with that, right? Like making sure there's people on Slack, on GitHub, and then honoring all of the touch points, that people might come with to try and contribute.
Yeah. I see that as an engine, and it's an engine we're building. So there are things where we do pretty good. There are things where we need to improve, but we're also learning on what are the best motion we need to put in place for that to happen flawlessly. But there will always be people who just don't want to have to do with the community, just want to leverage Airbyte their own way, and it's absolutely fine. That's why also we open.
The interesting thing about you guys too, about Airbyte, is that it's not just like one open source project. In some ways, like every connector is like its own project, right? Like you could have like some people that are like, I want to build the connector and maintain it, and like this is my baby and everything. Then some people are like, just poop something out, and then they're like, yeah, someone else can take it from here. And so like it's like there's like almost like a subculture for each connector or destination, and it's like pretty interesting.
Yeah, that is true. And that's actually exactly what we're trying to build with the maintainer program, is figuring out, are there some connectors where people really want to own the outcome of it? And that's why it's as you said, every single connector, and we've built it in that way, could be a separate project.
Is it in different repos today, or is it all in the Airbyte repo?
Today it's all on the Airbyte mono repo, but we're looking at what can we do to split them away from the mono repo while still keeping track of or indexing connectors. But the thing is, because we were building the good practices, because we're building the protocol, we needed first to have everything to be very, very centralized so that we can enforce that within the repo. Now that we have the tools, it's okay. You can take it out, and things will be enforced for you.
I can imagine someone wanting notifications for one tiny connector and then getting notifications for the entire Airbyte.
So you want to watch the repo and then be really on top of it. But if you start watching the Airbyte, you just get hammered. There's some stuff you can do with the code owners on GitHub.
I know. Yeah.
I think you probably want.
But there is also a security thing at that point, which is by letting maintainers should have the right to look at PRs, decide to merge them with the contributors, and contributors should be able to just contribute easily to it. Merging to the master branch, if you have 1,000 connector, you're exposing your community to a risk. So this is something where you need to be careful. Like someone might change something in the platform that will break, and you won't see it because you have 1,000 connectors on your project.
Yeah.
It's very easy to miss it. And also it's a bit daunting to have such a large project. So at that point, just like, let's make it very, very contained so that if there is a problem, it's only a problem for this connector instead of the platform.
So it's a mono repo. Is it multiple Python packages though? So one package for each connector, or just deploy? When you deploy, you get all the versions of different connectors.
No, it's every connectors you can work on them independently. Whether they are Python, JavaScript, Java. The language doesn't matter so much.
They all have their own version and say NPM package or Python package. There's different packages.
And there's
mono repo.
There's like a central Airbyte UI where you can install them too. Because I've used Airbyte a bunch. The last year I did, and it's pretty cool. It's like an operating system, and then you like install a bunch of connectors, and you can have them in different versions, and you can upgrade the operating system itself. So
yeah. We've always made sure that they can be split out of the repo if we need to. They are not tied to the platform.
Yeah, like breaking into like multiple repos or some of the plugging packages into their own repo would allow I think for more decentralized ownership, right? Because people could like watch those repo, process the pull requests. I was just looking like at the Airbyte repo, and it looks like you guys have like 264 open PRs. So I think like you suffer from success the same way that we do with Apache Superset, which is like, hey, we couldn't pay enough people at preset to like really honor all the PRs that are coming in. And then if we could, I think that would bring more PRs, right? So it's like, oh, well, if we offer a better service in terms of like onboarding people in the community, then I think more people will come, which is kind of what we want. But it's like at some point you have to decide how much you're going to invest in like supporting newcomers in the community that are trying to contribute. And it's such a sad thing that you would have like a beautiful bug fix or feature enhancements for connector, and the PR would stay open for 2 weeks before anyone looks at it. But at the same time, is it possible for any organization to really like solve?
Yes, I would say in terms of like merging connector PRs and reacting to it, this is one place where we have a good velocity. If you look at the 250 PRs, I'd love to know the ratio between what is platform, what is draft, because we also have a team behind. We have a team of contractors. We have a team within Airbyte. So,
or just think that should have been closed. There's PRs that are just like, hey, listen, this is we're not really looking at it, reviewing and closing it because we don't really know who should do this. This probably doesn't fit the project. So some of it's just like triaging, right? Like I think for us, we're not doing better, by the way, on Superset. I'm sure we have like as many or more PRs open, but a bunch of that list is probably things that will never make it and probably should be closed and say like, reopen, if you can do X or. Yeah. And that's why like the maintenance program is important for us. And like the fact that as you said, every single connector can be a separate project that will allow us to go much faster also on like triaging and having people have ownership on what should happen with that connector. Yeah, and you can look on the repo on like the Insights tab or just see like last activity on the repo. It's really hard to do that with a mono repo to say like, how much activity is there in this subfolder is not really something you can answer on GitHub. But if every like you know what you can do? You can connect Airbyte GitHub to BigQuery or to Snowflake, and you can have much more advanced analytics. We do have this type of analytics. So that's like I think that makes tons of sense too. And even like that, this like whether the connector is maintained. Maybe that's not information that's easy to get on GitHub, but at Airbyte, you can see like, the maturity lifecycle and like who's the owner and the number of PR. So you guys can kind of untangle that and make that have a page for the connector where you really show whether, its current state. And especially around usage. Usage is really the key thing. Like a connector dies if it's not used because it depends on the system. If you don't follow the evolution of that system, then after 3 months, it's going to be obsolete.
Yeah.
So
Makes sense. Cool. We just have a few minutes left. So I did want to touch on one last important area, which is, so Airbyte, bought Grouperoo, and you guys are kind of expanding to reverse ETL as well. Presumably there's overlap in the problems, and it's cool that Grouperoo is also, open source. So like how do like Airbyte users benefit from Grouperoo, and also just like how different is the problem of kind of pulling data out of APIs, third-party APIs, versus sending information back to them? Because I think a lot of people might think they're the same, but they do seem to have their own unique problems.
Yep. So it's that's a good question. So yes, reading data is different from writing. Writing, like if you read and you know how to deduplicate, you can read multiple times. It doesn't matter. Writing into a system that you don't own, you don't know what's going to be the impact of writing multiple times. So first of all, you need to know your guarantees in terms of one-time or n-time deliveries, and is that an idempotent operation or not. Then rate limitings for write are even tighter than what they are for reads. The other one is when you do reverse ETL, there is also a piece that's happening in the middle that nobody really talked about, which is you need to do identity resolution, which is you're pulling data from Zendesk, you're pulling data from Salesforce, from HubSpot. How do you make sure that the three records that you got from these three services get joined at the end so that you can have the full vision of who, if you're taking like a customer use case, like who that customer is. So that is also something that needs to be solved within the warehouse to understand joining identity.
Yeah, right. Like that's a huge part in data integration. Is just like an identity management. You need a natural key of some kind that just like uniquely identify an object across system. So that means that I think that stuff is really important, and that means that your master, or historically we call it master data management, but a big part of it was to make sure that all the hub and the spokes from the hub add information about that. Call it master key. I guess the term master, we shouldn't use it anymore, but like the central, call it unique, like truly unique, like UUID that really truly identify like a natural object with your company outside of like, the ID in the different systems. So that's still not all that easy to do. Like you have to create these custom properties and systems, or they don't always like let you manage that key as in a way that is as important as it seems, right? So you'll put your UUID in some like custom property in a HubSpot. You're like, wait, no, you should no. This is a very special attribute for this object. It's my key. You should treat it like as a primary, like really important field.
Exactly. So this is one thing that needs to be resolved with reverse ETL. It's not just about the movement of data. The other one is, because you're integrating with operational system instead of warehouses, this goes more into the realm of automation at that point. And you need to also understand what is the cost of not sending the data. Like if the data is corrupted, if the rights of the data is not working, what is the impact behind the scene? And we always talk about this Maslow pyramid. At the top, it's way more like the impact on revenue is almost immediate. And here you need to understand, okay, you're pushing data, but the impact on your revenue, you will see it right away. If you mess up something, if you improperly send segments to HubSpot and suddenly you're sending the wrong campaign to people, you will see it right away. So the impact is even stronger. So you need to make sure that your system it must work. You don't have time to. It's automation. It's almost real time. It needs to work. If it doesn't, it will have an impact.
That's a super scary thing, and like for the data practitioner out there, like once you start doing reverse ETL for like mission critical stuff, like your data warehouse is a production system.
Exactly.
Right. And then historically, it's not been treated as such, right? Like I'm not sure if like anyone to say like BigQuery or Snowflake is part of my production stack. You're like, wait a minute. Let's create at least a different project for this, right? And really, and have a different SLA, because the data warehouse historically has been like a big messy place with like tens of thousands of tables that, people are welcome to write, Airflow and DBT script at will. And then there's like, typically you have a service account that has a bunch of access to everything, and I can go drop tables if I want to. then you're like, that doesn't seem to work to support reverse ETL. Like we're gonna have to create a pipeline with some level of installation for that. And I haven't seen personally any like reference architecture for that stuff. Like I think like the world is dying for someone to say like, how do we use something like Snowflake BigQuery best for mission critical like production supporting analytics use cases? And today I think like if people ask me about it, like, oh, just create a different Snowflake BigQuery project with a different credential and try to make this one cleaner. And then that means you probably need a different like DBT or Airflow DAG. And that means Airflow and DBT now are also production grade system that if they go down, you need to, historically they've also not been treated as such. So I think we're going to see the emergence of production grade, analytics pipeline, parallel, architecture for this stuff. And today's, it's kind of scary the way that some of these things are built. If you look at how people do reverse ETL to support, mission critical campaigns and things like that, you're like, oh my God, is that okay?
Yeah, and that's one of the reasons why whenever someone talks to me about reverse ETL, I always bring it back to it's an automation system. It's not reverse ETL. When you're talking about reverse ETL, you want to apply like the latency you generally have in data teams, and it's not true. So reverse ETL is a word that should only belong in the data engineering space and should not belong in the automation space. So just, I like to reset expectation on what reverse ETL actually is.
So then would you say that, so we would say like if you have mission critical things like campaigns that those should not use reverse ETL and should probably use like some sort of like RPC or like some other kind of integration that's more reliable?
No, they should be using reverse ETL, but don't think it's the same thing as pulling data from a source to your warehouse. It is not the same. You need to have quality. You need to have you need to have so much validation around the data that's going to be sent. That's the only thing. And people might have a tendency to underestimate that.
Yeah, I think or people will just bucket it, right? Because it's the same systems, it's the same people, and they have this bar that's kind of low because it's like internal systems, and and we value like velocity over like predictability and like cleanliness. I think in general for internal analytics, but I think like if you go to engineers or data engineers and say like, hey, this pipeline is special, and you're gonna have to isolate it from the rest and be really cautious here. People are like, yeah, it's fine. I'll just, it's like, I'll just do my best. Right. And I don't think that works well.
Yeah. So, and same thing, like lineage at that point, when you do reverse ETL, it is key. You need to have lineage. You need to understand exactly how you've computed this particular piece of data. And you need to have some quality along like every single step that has happened to get to that record. So like it's way more integrated. And that's why reverse ETL is at the top of the pyramid. People should not forget to build the intermediate level.
Or at the top of the house of card is a different way to put it, right? And that's the thing. A lot of people will just like latch. I mean, that's the way we did it too. We latch our reverse ETL solution on top of the warehouse as it was, and we
do as well. We do as well.
So we haven't done like a special pipeline with a special project with a special DBT project where the rigor would be cranked up to 11. But I would love to see some like reference architecture for that, right? It's like, okay, how do we create special places in our analytics pipeline data warehouse, like special little areas that are like where the rigor is like cranked up to 11 because it supports mission critical stuff. Yeah, and I think like, Snowflake and these companies will tell you like, oh yeah, no, we totally support production workflow. It's kind of by accident. I don't know if it's I think we're getting to a place where maybe it's okay now, but historically it's just like, these systems maybe were not ready for them. They're not predictable enough.
But it's really distinct. Whenever you're doing a data project, you need to understand, is it an analytics project or is it an operational project? Because both of them, you should handle them very, very differently. And every data team should always, at the beginning of every single data project, think about what branch am I taking? Because you won't apply the same processes, and the impact of like problems is going to be different whether it's one or the other.
Yeah,
right.
And I'm not sure if that seems spectral, right? It's not necessarily like, oh, it's a binary, like operational or analytics. It's like, oh, where on that spectrum is it? And there's a lot of like, let's say if you take something like product analytics type stuff that you feed in your CRM. So for us, it might be like, oh, we want to see how many active users a customer has, how many monthly active users a customer has. So that means we're doing analytics workload, right? To compute over a month means like, it's something batchy, something that relies on in a different area. And then we push this data out, maybe to score PQLs, like maybe to score our product qualified lead.
Yeah.
But then, and it's like, PQL is not a really important thing, right? Or it's okay if it breaks for a day or two because it's not such a production critical thing. But someone else in HubSpot might latch a campaign on top of that uses that MAU metric, and all of a sudden it got derived in a way that it is mission critical and an operational mission critical system without necessarily the data engineers even knowing about it. So I think it's like messy by nature, and we'll see how it evolves, but it's either we raise the bar across the spectrum of data engineering, or we create this special place. And creating a special place is really hard.
Yep.
Right. Cool. Well, hey, we're at time. I know we keep talking for a few more hours, but want to be mindful of both your time. So thanks, Michel, for coming on. We should do this again sometime. If you guys don't have a podcast, you guys should definitely do one. It's a lot of fun. So
sounds good. I'll take that.
Tell Sean to start a podcast.
Super clear to me that data integration is not solved, right? And I think it's really curious to see how this evolves. Like, there's some topics we haven't gotten into. We can save for next time, but how maybe eventually the way that we share data and integrate data would be for companies to open up parts of their warehouse, right? So say if HubSpot could expose a Snowflake, area on my data, so we don't even have to transfer the data. So the cloud data warehouse, and in theory, could make it a lot easier for people to exchange data. I think that's an interesting avenue for the future.
Yep, it is.
Awesome. Cool. Well, thanks, Max. Thanks, Michel. And have a good rest of the day.
Thank you, Max.
Thank you.